Hello dear students, welcome to BYJU'S Exam Prep. Now under this PYQ series, we are solving IIT Kanpur GATE questions which were asked in year 2001, 2007 and 2015. So I welcome all for this particular session, my dear friends. Okay, so let us start this PYQ series, my dear friends. Before starting, this is about me, myself Sridhar Dhulipala. I am having 20 plus years of teaching experience and my qualification MTech Saka from NIT Karnataka Surathkal and MSc Mathematics from JNTU Hyderabad. And I am associated with BYJU'S from past 1+ years, and under BYJU'S Exam Prep app you can find this particular category which is named as Learn with Video Lessons, where you can find all these subjects which were recorded by me: Discrete Mathematics, Algorithms, Engineering Mathematics, C Programming and Data Structures. And in today's class we are going to discuss about the previous year GATE questions of IIT Kanpur which were asked in year 2001, 2007 and 2015, my dear friends. Okay. So without wasting much of your time, let me start with this PYQ, my dear friends. Hope all of you can hear me. All of you can hear me loud and clear. Please message me. Just 1 second. You can think about this problem, sir, meanwhile. Yeah, now I think it's fine. So let us start the story. Hi Sahil. First problem, how many 4-digit, see here we have so many problems, so I quickly solve the problems. It's not like you solve again, I wait, I'll solve it. If you can solve together with me, it's fine, otherwise you can see the solution, my dear friends. Okay, how many 4-digit even numbers have all 4 digits distinct? See my dear friends, here what you want is, you want a 4-digit number in which all the digits are distinct and it should be even number. So you want a even 4-digit number with all distinct digits or without repetition of digits you want, my dear friends. Okay. Now please tell me, what do you mean by even number? An even number should end with either 0, 2, 4, 6 or 8. That is, there are 5 possibilities where you can fill the last position, my dear friends. Sir, I have completed first year 2022 July. When I will give GATE examination? Is it a GATE question for me? You can give your GATE question in in your 3rd year, my dear friends. Okay, when you are in 3rd year and when you are in 4th year, you can write it. So you have to prepare for 1 more year. Maybe, okay, 22nd July you completed first year, 2023, 2024 GATE examination you can give. Okay, if you are asking me a GATE question, that is the answer for your GATE question, my dear friend. Right? My dear friends, but there is one important point which you need to note here, my dear friends. What is that? This is an even number without repetition of digits. An even number can end with either 0, 2, 4, 6 or 8. Now, if it end with 0, the story is simple, sir. If it end with 0, the story is very simple. Why, sir? It can end with 0 in only one way. Because repetition of digits not allowed, the first position now can be filled with 9 ways. Because 0 is already done, we don't have to start with 0, my dear friends. Now this can be filled in how many ways? Because 1 digit already placed here, 8 more ways you can fill this position. And this position can be filled in 7 ways, my dear friends. See, it depends, my dear friends, generally. Okay. See, generally they mention like 50 plus is a good score for PSUs. For computer science, we have less number of PSUs, but anything above 50 is a very good marks, my dear friend. 50 से ज़्यादा है तो सेहत के लिए अच्छा है, minimum. Don't just qualify, get some good marks, right? This is about when it is ending with 0. What if it is ending with 2, 4, 6 or 8? See, how many ways it can end with 2, 4, 6 or 8, sir? 4 ways. 4 possibilities are there. Now, when it is ending with one of the number, one number is already gone, we are having 9 numbers. But in the first position, you cannot put 0 because you want a 4-digit number, it cannot start with 0. So, here we have only 8 choices. Here we have only 8 choices. See, any batch, it is similar, my dear friends, more or less. It depends again, like, more or less 50 plus is a good mark. Aim for good marks, then you get better choices. That's it. Am I clear? Don't always worry about, what a minimum kitna aana chahiye. That is a bad way of, preparing for any examination. Okay, minimum kitna pass hone ke liye thodi likhte hai exams. Okay, so you need to aim for good marks. Prepare well, then give the examination. Am I clear? Now here you may feel 7 choices, but 0 can come here. So here 8 choices you are having. Then here 7 choices you are having. So the number of 4-digit even numbers without repetition digits is given by 9 into 8 into 7. So the answer for this problem would be 9 into 8 into 7. How much, sir? 504. 8 into 8 into 7 into 4, which is 1792. If you simplify, you get the required answer, my dear friend. The required answer should be 2296, my dear friends. And most of the people do mistake in this problem because they either end with, that is last digit they fill in 5 places, 5 ways, and again first digit 8 ways, 8 ways and 7 ways. This is how they solve it. But they never note that ending with 0 is a different situation than ending with 2, 4, 6, 8. That's why we have to separate these two situations, my dear friends, when you are solving this particular problem. So this is about solution for this problem, my dear friends. Hope you understand. No one answering? That is the first beautiful question, my dear friends. Actually, this was a linked answer question. I'll give you a simple formula. If you can remember this formula, such problems can be answered without any trouble, my dear friends. Am I clear? Suppose a robot is placed on the Cartesian plane. See, generally Cartesian plane, they also call it as lattice plane, my dear friends. At each step, it is allowed to move either 1 unit up or 1 unit right only. That is, if it is at ijth coordinate, it can move 1 unit up. 1 unit up means, okay, this is 1 unit right. I plus 1j it can move. It can move to I plus 1j, or it can move 1 unit up, that is it can move to ij plus 1 only. From a given point, it can move 1 unit right or 1 unit up only. No other movements are possible. No other movements are possible. Why you are willing to write JEE examination or what? Okay, JEE is a learning stage, so obviously the syllabus will be more. Okay, when you learn more. When you apply, only some of the concepts you apply. Am I clear? See, when it is a particular topic, it depends on that, my dear friends. I am just talking about JEE syllabus and comparison. Like mathematics I compared, similarly physics also. There are some topics which are done very basic level, done in an elaborate manner. But when you go for advanced topics will be covered in GATE. Okay, like that. Wonderful. Is it clear? This is what happening, my dear friends. How many distinct paths are there for robot to reach the point 10, 10 starting from 0, 0? That is, a robot is placed here, my dear friends. It is placed at 0, 0. 0, 0 to 10, 10. How many distinct paths are there? This was the question. Okay. See, for this I'll give you a simple formula. Remember, you can easily answer this question, my dear friend. The formula is simply like this. Number of distinct lattice paths we call them, or simply you can call them as paths. See, lattice path means the path which takes either 1 unit right or 1 unit up at each step, my dear friends. Okay, number of distinct lattice paths from x1, y1 to x2, y2. So, from x1, y1 point to x2, y2 point, if you want to reach, the number of distinct paths is given by following formula. The formula is x2 minus x1 plus y2 minus y1. You all know differences. C, either you can write x2 minus x1 or y2 minus y1, my dear friends. y2 minus y1. Am I clear? See, if you attend my class, I will tell you why this formula, but here it is only solving problems, so I am just telling you how to solve the problem. Am I clear? Like this. So, from 0, 0 to 10, 10, how many paths will be there? 0, 0 to 10, 10, how many paths are there? y2 minus y1 plus x2 minus x1, C either x2 minus x1 or y2 minus y1, that is 10 minus 0, my dear friends. That is nothing but 20C10. So the answer for this particular problem is simply 20C10, my dear friends. Direct formula, nothing more than that. Okay. Of course, you need to understand how you get this formula, that we will discuss when we discuss in detailed discussion, my dear friends. Okay. So here please don't expect detailed discussion, sir. Problem how to solve, I'll explain. Am I clear? Because I taken almost, there are around 25 to 30 questions, sir. Okay, not even given the numbers properly. So I'll give you the procedures quickly. Okay. See, it is for reference, my dear friends. Now look here. Suppose that robo is placed on the Cartesian plane. At each step it is allowed to move 1 unit up or 1 unit right. Same question. But here what is saying, suppose that the robo is not allowed to traverse the line segment 4,4 to 5,4. You are not allowing that particular robo to travel from 4,4 to 5,4 line segment. Number of distinct paths with this condition or with this constraint, how many distinct paths are there, we need to calculate, my dear friends. Means this is 0, 0. This is 10, 10. So it is 1, 2, 3, 4. This is 4, 4. And this is 5, 4, my dear friends. Now what you are mentioning, my dear friend, you are not allowed to take this particular path. That is 4, 4 to 5, 4, you are not allowed to take the path. How many distinct paths with this condition? That is, we need to find number of paths. We need to find, of course, number of lattice paths, not using 0, sorry, not 0, it is, one second, it is not using 4, 4 to 5, 4 path, not using 4, 4 to 5, 4 path. So this is the question, my dear friends, not using this particular path. See, not using this particular path means what, sir? You need to identify, you need to write all the path. In that we need to check whether this path is there or not. The best way is, instead of doing directly, from total number of paths, you find total number of paths, you subtract number of paths going through this particular line segment. Number of paths through this particular line segment, that is 4, 4 to 5, 4. So with this what happens, from total you remove all the paths which pass through this particular line segment, you are going to get number of paths which are not passing through this particular line segment. This is a very simple problem, my dear friends. Am I clear? Now you already calculated in the previous problem total number of paths, which is 20C10. Now we need to find number of paths going through this 4, 4 to 5, 4. See, if you want to go through this 4, 4 to 5, 4, first of all, by some means you have to reach this point. Then you have to travel this. Then from here to here you have to reach. That is 0, 0 to 4, 4 you have to find path. How many paths are there from 0, 0 to 4, 4? 0, 0 to 4, 4, how many paths are there? Simply same formula. y2 minus y1 plus x2 minus x1c, either x2 minus x1 or y2 minus y1, which gives you 8c4, my dear friends. Then again 4, 4 to 5, 4, it is single line segment. Now 4, 4 to 5, 4 is a single line segment. So it is simply 1 directly you can write, my dear friend. Then the important flow is 5, 4 to 10, 10. How many paths are there from 5, 4 to 10, 10, my dear friends? You can study all that, my dear friend, no problem. If your time permits, you can study anything of your interest. There is no restriction for that. Okay? There is no restrictions. Okay? Now, 5, 4 to 10, 10, how many paths are there? 5, 4 to 10, 10. I'll just write here 5, 4 to 10, 10, how many paths are there? That is 10 minus 5 plus 10 minus 4. C, either 10 minus 5 or 10 minus 4. I'll write 10 minus 4, my dear friends, or 10 minus 5, let me write. So what is it? 5 plus 6, 11, C, 5. So the number of paths going through 4, 4 to 5, 4 is given by, first you have to go from 0, 0 to 4, 4, that is 8C4, followed by this particular line segment, that is 1, followed by 5, 4 to 10, 10, that is, what is it? 11C5, my dear friends. So the correct answer for this problem is option D. Is the idea clear? Yes or no? It's a straightforward question, my dear friends. See, if you want to answer, I'll give some time, my dear friends. Otherwise, quick session, I'll complete all the questions. Okay? It's a very quick review of all PYQs of IIT Kanpur, my dear friends. Okay? Next problem. This is also very interesting, very regular gate question, sir. Number of divisors of 2100. How many divisors are there for 2100? See, for this particular problem, first of all, we need to do the prime factorization. What we need to do? Prime factorization. So, in prime factorization, what is it? 2100, 2 ones, 0, 5, 0. Again, 2 5s, 2 2s, 2 5s, 3 ones, 3 7s, 3 5s, 3 will not go, 5, 5 3s, 15, 25, 5 7s. So, the prime factorization of 2100 is given by 2 square into 3 power 1 into 5 square into 7. Actually, this problem you can also see in your aptitude, my dear friends. Some of basic counting questions you can also expect in your counting, my dear friends. If you study the counting topic of your discrete mathematics, you can also score some marks in your aptitude also. Of course, in probability based questions also you can confidently solve, my dear friends. So, that is the advantage which CS people are having, because you study counting from very basics. So, your counting is strong, therefore, your probability is strong. Again, some counting based questions can also be asked in your aptitude. There also you become very, very strong, my dear friends. See, discrete mathematics is a very basic subject, very, very big scoring subject. Generally, people feel discrete mathematics is theoretical subject. There is no theory, sir. Entire thing which I do in discrete mathematics is problems, problems, problems. We do entirely problems only. It's a very, very logical subject, sir. Very, very logical subject. Now, you write the prime factorization. Then the number of divisors you can find by the following simple idea. This is the shortcut trick. Let me write the trick, my dear friends. People like this. Got it? So, once we have tricks, what we need to do, sir? See, every power is there, no power. 2, 1, 2, 1. See, for every power, add 1. Next power is 1. For that also, you add 1. Next power is 2. Add 1. Next power is 1. Add 1. Multiply, you will get the required answer. 3 into 2 into 3 into 2. That is 36, my dear friends. It's a gate question. 2015 IIT Kanpur. Very recent. Hope you understand. Okay, I don't even need additional slide for this, sir. In a single slide, we solved it. Next problem. This is a very interesting problem. Actually, this is a very, very interesting problem. There are many ways we can handle it. I'll give you a simple method for solving this problem. Number of 4-digit numbers having their digits non-decreasing order. See, non-decreasing means actually increasing with equal fellows together. See, for example, 2, 3, 4, 4. This is non-decreasing. Actually increasing, you may have equal numbers together. Increasing only, but equal fellows also be there. That is, it is with repetitions, my dear friends. Okay. Hello, sir. Very good evening, sir. Very, very good evening. Okay. Now look here. The number of 4-digit numbers having their digits in non-decreasing order from left to right. From left to right, constructed by using the numbers 1, 2, 3 only. That is, using 1, 2, 3 only, we have to create a 4-digit number. And what is one more condition, sir? The numbers must be in non-decreasing, that is increasing order. For example, if I use 3, I cannot use smaller than 3, sir. I can use all 3s. This is allowed. After 3, 2 is not allowed. After 3, either 3 or next number is only allowed. After 3, 3 or next number is only allowed. Am I clear? So, for this, let me give you one simple idea, my dear friends. Okay, instead of solving this 4-digit number, first let us consider 1-digit number starting with 1. Okay, I will just write it like this, sir. I use this Cij for this. Cij means, okay, Cij means it is starting with I, j digit number. starting with I just use this notation, my dear friends. So here, starting with one digit number. Starting with one digit number. How many are there, sir? Starting with one digit number. See, one digit number starting with only one number is there. Starting with two one digit numbers, how many will be there? Only one fellow. Starting with three one digit numbers, how many will be there? Only one fellow will be there. Correct or not? Yes or no? Now, if you want to have starting with one, but you want two digit number. Starting with one two digit number. So it is starting with one, you want two digit number means what should be the second digit? Because it is non-decreasing order. Now second digit can be 1 or it can be more than this also. That is, second digit can be either 1, 2 or 3, my dear friends. So if it is starting with 1, the second digit can be either 1, 2 or 3. See, this is starting with 1 and one digit number is 1. Starting with 1, one digit number is 1. Starting with 1, starting with 3, one digit number is 1. So starting with 1, two digit numbers, how many you can get, sir? 1 plus 1 plus 1, which is 3. Of course, it may look little odd, but now I'll make it simple for you, my dear friends. I'll make it simple for you. It is starting digit. Here I am writing starting digit, sir. Starting digit for me is, it can be either 1, 2 or 3. And here on the row I am writing number of digits. Now please tell me, starting with one digit numbers, how many are there? We already seen 1. Starting with one digit number is 1. Starting with 2, one digit number is 1. Starting with 3, one digit number is 1. Now I want starting with one two digit number. See, when you say two digit number, starting with 1 means first digit is 1 fixed, but second digit can be either this or this or this. So simply add these three fellows, you get this answer, my dear friends. Because if it is 1, second digit can be 1, second digit can be 2, second digit can be 3. That is, these possibilities you can simply add to get this answer, my dear friends. Now, starting with 2, two digit number means first digit is 2, but second digit can be either 2 or 1. That is, just add these two only. So for this, you just add these two only. That is 1 plus 1, which is 2. 1 plus 1, which is 2, my dear friends. Then, starting with 3, two digit number. See, 3 means next fellow also must be 3, only this number. So answer for this is 1 only, my dear friend. Answer for this is 1. See, what you are simply doing is, for this you are adding all the three numbers. For this, from this you are adding all the number. For this, from this you are adding all the numbers. That is the logic, my dear friends. Am I clear? That is the logic. Now, starting with one three digit number. So what I told you now, just add all these numbers. 3 plus 2 plus 1, which is 6. Starting with 2 three digit number. For this, what you do simply add these two fellows. 2 plus 1, which is 3. And starting with 3 digit number, that is only 1. From here, remaining all you have to add. Now, please answer this question, sir. Starting with 1, how many 4 digit numbers are there? Starting with 1, how many 4 digit numbers are there? Starting with 1, how many 4 digit numbers are there? So for this, what we need to do? Add all this. Because starting with 1, when you want 4 digit number, it can be starting with 1 3 digit number, or starting with 2 3 digit number, starting with 3 3 digit number, which is already available for us. Just add these fellows. 6 plus 3 plus 1, which is 10, my dear friends. And what about answer for this? Simply add these two fellows. 3 plus 1, which is 4. And what about answer for this? It is simply 1, my dear friends. But what you want? 4 digit number starting with any fellow. This is 4 digit number starting with 1. This is 4 digit number starting with 2. This is 4 digit number starting with 3. But you want 4 digit number with non-decreasing order. So that is given by 10 plus 4 plus 1, my dear friends, which is 15, my dear friends. कोई बात नहीं, एक बार रिकॉर्डिंग देख लो अभिषेक. If you not attended morning session ना, रिकॉर्डिंग देख लो. See there what you are doing, sir. Here it is 1 1 1. For this what you are doing? 1 plus 1 plus 1 3. For this what you are doing? 1 plus 1 2, and it is simply 1. And for this 3 plus 2 plus 1 6. Here 2 plus 1 3. For this 1 directly. And this is 6 plus 3 plus 1. That is 10. Here 3 plus 1, that is 4. Here it is 1 directly. But you want all the fellows nest, it can be starting with 1 or it can be starting with 2 or it can be starting with 3. So it is 10 plus 4 plus 1, my dear friends. Suppose if it looks little odd for you, the one more methodology for this would be simply you can do starting with 1. What can be the next fellow? It can be 1, it can be 2 or it can be 3. Again, if it is starting with 1, it can be 1, it can be 2 or it can be 3. Like that you can write the complete tree, my dear friends, where you can calculate total equal to 15. Like that also you can do it, my dear friends. This is one more suggestion for you people. You can try like this, or if you understand this logic, within no time you can answer this question, sir. Actually this is, we are storing the values and reusing it. It's a dynamic programming approach, nothing more than that. It is dynamic programming approach, nothing more than that, my dear friends. Am I clear? This can be solved in two methods, but I will give you simple method here. Okay, the other methods, of course, for that you need to understand how to write recurrence relations. Okay, now I will give you a simple method for this. Suppose an represent number of bit strings of length n containing two consecutive ones. Number of bit strings of length n containing two consecutive ones. It should contain two ones consecutively. What is the recurrence relation for an? This is an is number of binary strings of length n containing consecutive ones, containing this particular pattern. I am just writing 1 1 pattern. I am simply writing it as pattern, 1 1 pattern. You want to answer this particular question, my dear friends. So what we do is, we will find A1. How many binary strings of length 1 contain two ones? Binary string of length 1 means either 0 or 1. उसमें two ones कहाँ से आएगा? From where you can get two ones? So it is not possible. So binary string of length 1 is either 0 or 1. There are no two ones in this. So number of binary strings of length 1 with two ones, not possible. 0 is the answer. How many binary strings of length 2 contain two ones? Anyone answering? Two ones. 0 0 0 1 1 0 1 1. Two ones wala only one hoga. That is A2. That is only one. How many binary strings of length 3 contain two ones? Binary strings of length containing two ones. Write down all binary strings of length 3. Two ones wherever you find, that you identify, my dear friends. Two ones. Consecutive ones it should be. Consecutive ones it should be. Okay. How many are there, sir? Okay. A3 will be, A1 is 0, A2 is 1, A3 will be, how many binary strings of length 3 with two consecutive ones? You all know how to write it, 0 1 0 1 0 1 0 1. Alternatively write 0 ones, then write double the number of zeros, double the number of ones, double the number of zeros, double the number of ones. Again double the number of zeros, that is 4 zeros, 4 ones, my dear friends. So two consecutive ones are in this, are in this, are in this. How many are there? 3 are there. How many are there? 3 are there. Now what about this A4? How many binary strings of length 4 contain two consecutive ones? Write down that 16 numbers. In that, how many are having two consecutive ones? You calculate, my dear friends. And that is given by, I think 8, I think. It is 8. Please note that. Please check this. It should be 8. Am I clear? Now, what we do is, we verify each and every option. Option A says an is equal to an minus 2 plus an minus 1 plus 2 power n minus 2. Now what we need to do is, because base condition, because it is recurrence relation of order 2, two conditions we have to use. So let us take this A1 and A2 as base conditions. So we start calculating A3, my dear friends. What is A3 from this? From this A3 would be 3 minus 2, that is 1, and 3 minus 1, that is 2, plus 2 power 3 minus 2, that is 1. And what is A1, sir? 0, A2 is 1 plus 2, which is 3. Is A3 3 correct? A3 3 is correct. So this is the correct answer. But sometimes more than one options may be giving correct answer to you. So you have to check the other options also for this, my dear friends. So let us check option B. An is equal to an minus 2 plus 2an minus 1, an minus 2 plus 2an minus 1 plus 2 power n minus 2, my dear friends, 2 power n minus 2. Am I clear? Now, here what is A3? A1 plus 2 A2 plus 2 power 3 minus 2, that is 1. Now, what is A1, sir? 0. 2A2 is nothing but, what is A2? A2 is 1 or 2 plus 2, but it is 4. Wrong. So, if you can remove the options like this, the one which satisfies this particular condition is the correct answer. So, obviously, I think A is the correct answer for this, my dear friends. But for safety purpose, you have to check all options, my dear friends. Sometimes there may be more than one option satisfying this particular condition. In that particular case, you have to verify A4, my dear friends. You have to verify A4, my dear friends. And I think for this problem, option A is the correct answer by verification method. It is just done by verification method, my dear friends. Of course, you can also derive recurrence relation, but it is beyond the scope for this particular session. So, I am not doing how to derive the recurrence relation. I just use the simplest way, that is verification method, my dear friends. So, option A is correct answer. Now, this was logic. Now, we will see some logic questions. So far, I done some counting questions. Now, let us see some logical questions. Okay. See, in logic, first thing which we need to understand is, this is called an implication. P implies Q. An implication can be expressed. An implication can be expressed in multiple ways. Let me write the most important ways of expressing implication. An implication can be written or read as P implies Q. You can read this as if P then Q. You can read it as P only if Q. See, these are the different ways of expressing implication. See, my dear friend, here for logic or for expressing propositional statements, we need a meta language, helping language, and that helping language is English language. And some people misunderstand that we have to, expert in English language. No, sir. It is only a medium to express your propositions, my dear friends. So, we should not get carried away with, what is our personal feeling, how you interpret English statement, because sometimes you say some statements little sarcastically or little different ways. But here, when you use English language together with the logic, what we need to understand is we are only interested in the straightforward meaning. So, actually implication can be expressed in many ways, my dear friends, but we will fix those ways here for logical purpose. So, these are the standard ways of expressing an implication in English language. So, we will fix that. Like an implication can be expressed like P implies Q, if P then Q, P only if Q, or you can express it as Q if P. You can express it as Q if P or Q when P, or there is one more way like Q unless negation P. These are the different ways the same implication can be expressed in English language. Okay. Here what is the question? He given an implication and is asking what is the converse of that particular implication. But directly that is not given. One of the forms is given. You have to identify and see the correct answer for this. And for this, I generally give this simple method for this, my dear friends. See, if I see this, I stay only if you go. I stay only if you go. So, I simply call this I stay as a proposition S, and this only if you go, I simply call it as G, my dear friends. You go, I simply call it as a proposition G, my dear friends. So, this is the statement S only if Q. But if you observe, P only if Q is also P implies Q only. So, this S only if G, the symbolic representation of this particular statement. This is the statement expressed in English language. The symbolic representation of this S only if G is S implies G, my dear friends. This is S implies G is the symbolic representation. Now, what you want? Converse. What do you want? Converse. See, for every implication, there are three associated implications. One is called converse, inverse, and contrapositive. Here he is asking converse. For example, P implies Q is a proposition. The converse of this is given by Q implies P, my dear friends. See, for this implication, this is called converse statement. Converse. Converse of the implication. Am I clear? Converse of the implication is given by Q implies P. So, for this statement which is given, Our statement given is S implies G. What is the converse of this? What is the converse of this? G implies S. So you have to identify where is this G implies S. But even this G implies S can be expressed in different ways. What are the different ways? It can be expressed as G implies S. It can be expressed as if G then S, or it can be expressed as G only if S, or it can be expressed as S if G. See, there is a difference, sir. It is only if and it is just if. Please note that. And S when G, or S unless negation G. Now you have to identify which of the option is given in the options. Okay. Now look at this. What is it? S if G. Check whether that option is there. Yes. So correct answer is A, my dear friends. Actually, if you see this, S implies G. Okay, what it is S implies G, but your converse is G implies S, therefore it is wrong. If you do not go, then I do not stay. That is, negation G implies negation S. This is also not your contrapositive. Your contrapositive is G implies S, therefore it is also wrong. What is it? If I do not stay, then you go. I do not stay, then you go. This is also not correct option because you want G implies S, my dear friends. Because you want G implies S, my dear friends. All of you able to follow? Is the idea clear? Yes or no? One more question. Actually, in this there is some slight confusion for people, but the better option we have to take, so that's why we take one of the options. So let me explain this question, my dear friends. So there are two propositions which are given. F1 is P implies negation P. P implies negation P. See, negation can be expressed with tilde symbol or this 7 kind of symbol also people express negation, my dear friends. Now what is this P implies negation P equivalent to? We have something called law of implication. What law of implication says? P implies Q is equivalent to negation P or Q. So by that rule, this can be expressed as negation P or negation P, and that is nothing but negation P. But can you say whether it is completely true or completely false? Can you say it is completely true or completely false? No. When P is true, it becomes false. When P is false, it becomes true. But this can become true when P is false. This can become true when P is false. Because for one line of truth table, it is becoming true. We can call it as satisfiable. See, satisfiable means it should be true for at least one truth combination. It should be true for at least one truth combination. Therefore, we call it as satisfiable, my dear friends. Whereas F2, if you consider F2, P implies negation P or negation P implies P, my dear friends. Again, I use law of implication. P implies negation P according to this law of implication. If you apply law of implication for this, what happens? It is negation P or negation P, my dear friends. And what about this? P or P, my dear friends. That is, this is equal to negation P or negation P, which is negation P, and this is P or P, which is equal to P, and negation P or P is nothing but tautology, my dear friends, which is a tautology. Tautology means valid. Therefore, we say that F2 is valid and F1 is satisfiable. Option A is correct. So F1 unsatisfiable is wrong, F1 unsatisfiable wrong, but D option, some people argue this, like, whenever it is valid, obviously it has to be satisfiable. So there is nothing wrong to say this is also correct, but better option than this is this. Therefore, we go for this, my dear friends, because valid is better statement than what? Satisfiable. Because when it is tautology, we better call it as tautology. For example, you passed your 12th class and you passed your engineering. You say that you are 12th class student, or you say you are an engineer. You obviously say I am an engineer. So that is what we write. Am I clear? Like that. The next one. Which one of the following is not equivalent to biconditional? Which one of the following is not equivalent to biconditional, my dear friends? See, my dear friend, there are two important equivalences for biconditional. See, we study all this under, logic, my dear friend. Logic we study almost, 10 plus or 12 plus hours. but here this is only solving PYQs. I am solving the questions. Okay, you can just understand, okay, what type of problems will be there, how we handle. If at all you not known anything about logic, this is a good exercise to understand what type of problems, how this particular flow goes. You can understand that, my dear friends. Okay, whether they are difficult or easy, you can understand from these, right, my dear friends. Biconditional can be expressed as P implies Q and Q implies P. This is one fellow. And actually biconditional is true when both P and Q are true. When both are true, it is true, or when both are false, it is true, my dear friends. So these are two important equivalences for biconditional. Now he is asking which one is not equivalent to biconditional. So you need to identify odd man out, my dear friends. If you see first option, negation PRQ. Now there is no negation PRQ, but we have law of implication which says P implies Q is negation PRQ. Therefore, this can be written as negation PRQ, my dear friends. So negation PRQ, and this is P or negation Q. See, PR negation Q is same as negation QRP by commutative property. Therefore, this can be written as negation QRP or P or negation Q, my dear friends. Negation QRP, which is option A. Of course, we need to find the one which is wrong. We need to find the one which is wrong. So this is correct. This is not the right answer. Now, if you see option C, negation PRQ and Q implies P. Second part he not simplified. Only first part is simplified. This is fine. And option D is same as this one, sir. P and Q or negation P and Q. So, one second. So, biconditional is equivalent to these three fellows, but biconditional is not equivalent to this fellow. Am I clear? Biconditional is not equal to this fellow. Actually, okay, because of that, B is the correct answer for this. Actually, correct answer for this problem. Biconditional is not equivalent to that, but that is what he asked. He is asking which fellow is not equivalent to biconditional. This fellow is not equivalent to biconditional, my dear friends. Okay. This is a very interesting question. Logic question once again. If a candidate is known to be corrupt, then he will not be elected. If a candidate is known to be correct, then he will not be elected. Second statement, if the candidate is kind, then he will be elected. So here we try to identify propositions in this. If a candidate is known to be corrupt, okay, so let us use this proposition C as candidate is corrupt. I am not writing the entire statement. If you write that, you understand, no, corrupt means candidate is corrupt. Then he will not be elected. Second statement, candidate is kind, then he will be elected. So we can take elected as the proposition, then negation of elected will be not elected. Simply we can identify like that. Thank you, Abhishek. Thank you. Now, so what I do, this E as candidate is elected. Candidate is elected. And what about this candidate is kind? K I use for candidate is kind. So let us identify the given statements, my dear friend. What is S1? What is S1? If candidate is known to be corrupt, then he will not be elected. If he is known to be corrupt, then he will not be elected. So this is called symbolic representation of the given statement. What about second statement, my dear friends? What about second statement? Candidate is kind, then he will be elected. Candidate is kind, then he will be elected. See, my dear friend, we are having these two propositions. From this, what is the conclusion? You can get it. That is your question. Actually, if you observe this, it is like P implies Q, Q implies R form. You can only use transitive rule, my dear friends. But if you see first statement, C implies negation E. But second statement is K implies E. See, transitive tell you what, sir? P implies Q, that is P goes to Q and Q goes to R. Then we can say P goes to R. But here, these two are not matching. This is negation E and this is K. So here, for this, what I use is the contrapositive rule. See, there is something called contrapositive, and implication is equivalent to its contrapositive, my dear friends. So this can be written as negation E implies negation K. So first one is C implies negation E. Second one is negation E implies negation K. Now, here you apply this transitive rule. P implies Q, Q implies R, then P implies R. Therefore, C implies negation E implies negation K. Therefore, C implies negation K, my dear friends. C implies negation K. So, candidate is corrupt, then he is not kind. The corrupt person is not kind. If he is corrupt, then he is not kind. So this is what you made the conclusion. You made the conclusion that if he is corrupt, then he is not kind. But if you observe the options, first option is corrupt implies kind. He is saying corrupt implies kind. That is wrong. We say corrupt implies not kind, but he is saying corrupt implies kind. Wrong. Not corrupt, he is not kind. But what we got, corrupt implies not kind you got, but not corrupt implies not kind, also not correct for this. This is also wrong. But if you observe, he is kind, then he is not. If he is kind, then he is not corrupt. If he is kind, then he is not corrupt. If you observe this, this is your answer, but this is not matching with the given options. We can use the contrapositive of this. What we use? The contrapositive of this we use. What is contrapositive, sir? If it is P implies Q, negation Q implies negation P is contrapositive. The contrapositive of this is negation of negation K implies negation C, which is nothing but K implies negation C. That is, if he is kind, then he is not corrupt. If he is kind, then he is not corrupt, which is option C, my dear friends. Which is option C, my dear friends. Hope you understand. This is a straightforward question, sir. See, you may be finding difficulty because you do not know the rules of logic. See, generally, people don't even allow me to write the answer, sir. Immediately after seeing the statement, people give the answer. Because if you learn all these rules properly, systematically, it won't even take this much time which I am taking to explain you people. Am I clear? Only thing is, you just need to understand the idea properly. Am I clear? This is a very interesting question. See, this is my Telegram group, CS_Sridhar. You can join this Telegram group for PDFs of my class lectures. And in the morning, I am also taking complete C programming, my dear friend. Those who want can attend that particular complete C programming. Already we completed 9 sessions. Tomorrow is 10th session we are doing. Tomorrow's topic is functions, not mathematical functions, C functions. Am I clear? Right. This is a very, very interesting question, sir. It's a logical question. You can give a try for this, my dear friends. Please give a try for this. In a room, there are only 2 types of people. In a room, two types of people are there. Type 1, type 2. See, type 1 people always tell the truth. Sach bolne wale hain. They always tell the truth. They always tell the truth. Type 2 people always lies. Always tell the lies. They are the liars. Type 1 people are, okay, the truth saying people, where type 2 people are the liars, my dear friends. Now, you gave a fair coin to a person in that room. So, you taken a coin and you given a fair coin to a person without knowing which type he is from. That is, you don't know whether he is a truth person or a liar. But you just called one person, you given a coin to him and tell him to toss it and hide the result from you until you ask for it. So, you ask him, go and toss the coin, don't tell me the result until I ask you. So, this is what you told him. Upon asking, the person replies like this. Okay, so that person went and he tossed, he know the result, and later on you called him, tell me what is the output you got or what is the result of the toss. And that particular person also similar to you, he is also not giving you answer directly, he given the answer like this. This is the answer which he given. The result of the toss is head, if and only if I am telling the truth. So, ye bata ke chale gaya. Okay, he said that the result of the toss is true. The result of the toss is head, if and only if I am telling the truth. So, please tell me what is the correct answer for this, my dear friends. Can anyone try this? I think this particular session people are only interested in general discussions like is discrete mathematics scoring? Say, I can tell you, once you complete discrete mathematics, all these questions you answer without even allowing me to answer. I am telling you, sir, because you are not attended the class. Of course, I know that there will be some pain. Logic ठीक से समझना है. Logic we need to understand properly to answer such questions. Okay. Let us see option C is the correct answer. Let us say option C is the correct answer and see whether it is correct or not. We will check each and every option. See what that particular person said. The result is head. The result is head if and only if I am telling the truth. A option. Akash. Okay, very good. So the result is head if and only if I am telling the truth. So he given a biconditional statement. And for biconditional, yeah, very good. Akash, I understand. Okay, I think you already know the answer or you tried now. There are only two possibilities. Either you should know this answer already, or if you tried now and you got the answer means good. He given a biconditional. Now C option, what C option says, the person is of type 2 and the result is tail. Assume that he is type 2 and the result of the toss is tail. See, we know that type 2 person always tell lies. So type 2 person telling truth is false. Type 2 person telling truth is false because he is a liar. Whatever he says, that is wrong. And the result is tail. Now, this person told you this. It is head if and only if I am telling the truth. Suppose assume that he is type 2 and the original result is tail. Tail means what he said here is false. And he is telling the truth. Type 2 person telling the truth is false. So what he given is false if and only if false he given. He said that false if and only if false. But false if and only if false is what, sir? It is true. False if and only if false is true. Sorry, means that person given you a true statement. The person given you a true statement. Who? Type 2 person giving a true statement is wrong. Type 2 person giving a true statement is wrong. Therefore, this is wrong option, my dear friends. Because type 2 person cannot say truth. Now, let us say he is type 1 and the result is tail. Let us try this. Option D. He is type 1 and the result is tail. Now let us see what statement he given. The result is head if and only if I am telling the truth. The result is head is false. I am telling the truth because type 1 always tell the truth. So he is telling the truth is correct. So he said that false if and only if truth. False if and only if true. But false if and only if true is what, sir? Because biconditional is true. Biconditional is true. When biconditional is true, my dear friends? It is true or false? First you tell me, false if and only if true is true or false. When biconditional is true? Biconditional is true when both are true or both are false. When both are true or both are false, then biconditional is true, my dear friends. Okay, so this false if and only if true is false. But he is type 1 person saying false is wrong. Therefore, this is also wrong. Both are true. Which both are true? Both head and tail are true. Now let us see. See, the correct answer is, see, if it is tail and for type 1 person, this is wrong. If it is tail, type 2 person, that is also wrong. Therefore, this option also wrong. So the correct answer must be head. The correct answer for this must be head, my dear friends. The result is head. Let us understand this. See what he said. Head if and only if I am telling the truth. Assume that the answer is head and is type 1. Answer is head and is type 1. Answer is head is true. He is type 1 means he tell the truth is true. True if and only if true is true, my dear friends. And type 1 person telling the truth is correct. Suppose the answer is head and is type 2. Answer is head and is type 2. So head is true and type 2 person telling the truth is false. Truth if and only if false is false. And type 2 person can happily say the false. Therefore, it is also correct. Therefore, it is also correct. So, head is the correct answer, my dear friends. So, the result must be head, whether he is type 1 or type 2. If the result is head, this statement will result in correct way to the particular type of person. For type 1 person, this statement will be true. For type 2 person, this statement will be false. and that is correct only for type 1 person. Whatever statement he gives, that must be true, and for type 2 person, whatever statement he gives, that must be false. With that logic, the correct answer for this is option A. It is a logical question, my dear friends. It is a question from logic. A very beautiful question, my dear friends. The result is said. Akash, you are correct. I don't know whether you guessed or you given correct answer by identifying, but that is the correct answer, my dear friends. अगला समस्या आपके स्क्रीन पर. What is the correct answer for this? What about the next question? It is from set theory, my dear friends. It is from set theory. Now for a set, power set is denoted by 2 power a. You all know what is a power set? It is a powerful set? No. Power set is, we denote it as either with PA. Generally in theory of computation, you use this notation 2 power a, my dear friends. It is set of all subsets. It is a set containing all subsets, my dear friends. Now what is your set A? It is element 5, set 6 and set 7, my dear friends. Because A contain 3 elements, the power set contain 2 power 3, that is 8 elements, my dear friends. Power set contain 8 elements. See, for your understanding, let me write down the power set for this, my dear friends. Power set means empty set is definitely an element of power set, because empty set is subset of every fellow. Then all single element sets. See, this is like one element, this is like one element, and this is like one element, sir, like ABC. Okay. So element containing 5, element containing this element. See, here the element itself is a set. So it is element containing 6, that is set containing set 6, and set containing this element. What is this element? 7. So these are all called single element subsets, my dear friends. Then we go for 2 element subsets. 2 element subset means one element is this, second element is this. One is this and second is this. Or one is 5 and second is set 7, my dear friends. See, just see them as elements, then you will never do mistakes in this, my dear friend. It's a very simple concept. Then one more 2 element subset is the set containing element set 6 and element set 7, my dear friends. These are all 2 element subsets, and finally the 3 element subset is the set containing all that. That is the original set itself. That is 5, the set 6 and set 7. And this is your power set, my dear friends. This is your power set. I written complete power set, my dear friends. Now first question. Is pi belongs to means element of 2 power a. Yes, you can see pi, no? So this is correct. Super. Is pi subset of 2 power a? Blindly, without seeing also, you can say empty set is subset of any damn set in the world. So obviously this is correct. Obviously that is correct. Now what about this? You check whether it is belongs to means element. It should be in this. Set containing 5, 6. Yes, it is in this particular set. It belongs to is correct. But he is saying this is subset. No, this is an element of 2 power a, not subset. Therefore it is wrong. So 1, 2, 3 are correct. C is the correct answer for this. What is the correct answer? C is the correct answer for this, my dear friends. Hope you understand. All of you able to follow. Is the idea clear? Next, direct straightforward formula question, sir. And now we have some formula based questions. Directly apply formula, get the answer. Apply formula, get the answer. Sometimes, you know, in GATE, especially from discrete mathematics, there are some formula based questions comes. Apply, get the answer. Nothing more than that. Okay. Now here, this is a set. He is asking cardinality. What do you mean by cardinality? Number of elements in power set. Cardinality of power set. So let us call this set as A, sir, which is containing elements from 0 to 10. So tell me how many elements are there in A? How many elements are there in A? 0 to 10, 11 elements are there. Prajwal. Now formula based people started attacking. Super. A is containing 11 elements, then power set of A contains how many elements? 2 power 11. 2 power 11 is 2048, my dear friends. Super, Prajwal. Nizhara. Super. Good. That's simple problem, sir. It's a very latest 2015 question. I don't need even extra space. This is a very interesting question from set theory. See, it says U is power set of this particular set. So we are having a set which is 1, 2, 3, 4, 5, 6, and U is actually power set of S. Power set means set of all subsets. Set of all subsets. This fellow contains set of all subsets. Okay, this fellow contains set all subsets. Okay, nice. Now here is just giving some description for the problem, sir. T is a set in that power set. Mod T is denoting number of elements, cardinality of the set. T dash denotes complement of the set. What is complement of set, my dear friends? Universal set minus elements in this particular set will be complement of the set. Am I clear? Now, see, generally we write T minus R, but sometimes that T minus R is denoted by T, okay, forward slash R. They denote it like this, my dear friend. T minus R is denoted like this also. That is what he mentioned. T slash R is set of all elements in T which are not in R. That is T minus R. Now he is asking which of the following is true. See, actually, I just don't solve option A, option B, option C, option D like that, sir. I'll just go through all that. And if you observe, this is identifying whether the number of elements in X equal to number of elements in X complement, whereas all other fellows are with 5 elements. They are kind of examples. They are kind of B and C are kind of examples. But if you see D also, he is asking you to prove something. My dear friends, if you want to prove something, you have to give the proof. If you want to disprove something, give a counter example. Shoot out. Am I clear? If you want to disprove something, just give a counter example. It is done. Am I clear? So let us solve this. Oh. Now, if you observe the last option, D, actually D is the result, my dear friends. He is asking whether X slash Y is equal to Y complement slash X complement. This is what he is asking you to prove. Let me give the proof. If it is correct, you are done. Okay. So, because I am comfortable with minus sign, I just write this X slash Y as X minus Y, sir. Because I am comfortable working with minus sign than slash line. That is a different notation, nothing more than that, my dear friends. X minus Y. What do you mean by X minus Y, sir? X but not Y. See how you read it? X and sorry to Y. Say sorry to Y. Babu Y, go home. Okay, only I need X. I don't need Y. Now this can be written as Y complement and X. This can be written as Y complement and X. But if you use this formula, see, it is like X minus Y is X, X and Y complement. So you can also write reverse now. If X complement Y is what? X minus complement of complement. So this is also can be written as Y complement minus complement of complement X. Oh, sorry, not complement, sir, only one complement. Already only X is there, no? Complement of X you can write, which is nothing but Y complement slash X complement. Of course, he returns dash, I am writing C, nothing more than that, my dear friends. So this is the correct answer. So option D is actually a result. He's proved. He proved his, it's a direct result, sir, we can easily prove. Therefore, option D is the correct answer, my dear friends. What about the other options? You can give a counter example to say that that is not proper. For example, you consider a set with say elements 1, 2, sir. Then what is its complement, sir? Other than this, the elements other than this, that is nothing but 3, 4, 5, 6. See, obviously X is containing 2 elements and X complement is containing 4 elements, though this result is wrong. Like that, you just need to give a counter example to disprove the other fellows, my dear friends. To disprove the other fellows, you just need to give a counter example. Now here, the next example, there exists at least one X and at least one Y. One X is there and one Y is there, such that what? X is having 5 elements and Y is having 5 elements, but their intersection is empty. My dear friends, X can be made with these 6 elements only. Y is also made with these 6 elements only. If you want these two elements are different, you should have total 10 elements. I am having only 6. From that, how can you get 10 different elements? I need to do some magic or what? So this is never possible, my dear friends. This is never possible. Similarly here, for every set containing 2 elements and for every set containing 3 elements, X minus Y is empty. See, for every, he said, now you just give one example where a set containing, 2 elements, for example 1, 2, and a set containing 3 elements, say any other 3, 4, 5. But what about x minus y. X slash y is nothing but x minus y. X minus y is what, sir? Elements in x but not in y. That is 1, 2 only, which is not empty. So this is also wrong. Wonderful, wonderful. See, whenever you get such problems, you have to eliminate the cases, my dear friends. So people also solve it by elimination of cases. And remember one important point, my dear friend, if you want to prove it, you have to prove for every case. If you want to prove it, you have to prove it for every case in the world. But if you want to disprove, we just need to give one counter example for that. Just need to give one counter example for that, my dear friends. This is also formula based direct question. You can try, my dear friends. See here, x and y denotes sets containing 2 elements and 20 elements. X is a set containing 2 elements and y is a set containing trying. Okay, try. Because so many questions are there, if you keep on trying, the entire full day will be wasted. So that's why, I am just solving the question, because we need to solve all the questions, no? That's why. And in 1 hour time, we hardly solved how many problems? 13 problems I think we solved. Yeah, very good, Prajwal. Very good. 0.95. Good. See, the problem is very simple. X is containing 2 elements and y is containing 20 elements. F denotes set of all possible functions defined from x to y. F denotes what? Set of all functions from x to y. Now please tell me number of functions from x to y, total number of functions. How many functions are there? The number of functions from set x to set y is given by the formula number of elements in y power number of elements in x. Number of elements in y is what, sir? 20 power number of elements in x is 2. 20 power 2 or 20 into 20 or 400, my dear friends. Then he is asking a function f is randomly selected from this collection. The probability that this function is 1, 1. So we need to calculate number of 1, 1 functions also. We need to calculate number of 1, 1 functions. See, this problem combines the concept of function with probability, my dear friends. Very good, Prajwal. Very good. Number of 1 to 1 functions. The number of 1 to 1 functions is given by the formula number of elements in the second set, P number of elements in the first set, my dear friends. That is 20P2. Now what is that he is asking, sir? He is asking you to find probability that a randomly selected function is 1, 1. So what is probability, my dear friends? Favorable number of cases. Favorable number of cases divided by total number of cases, my dear friends. So what about favorable number of cases? Number of 1, 1 functions. Because what is the probability that it's a 1, 1 function? So how many 1, 1 functions are there? 20p2. If you want, you can simplify this. 20p2 is what, sir? 20 factorial by 20 minus 2 factorial, which is nothing but 20 factorial by 18 factorial, which is nothing but 20 into 19, my dear friends. So favorable would be 20 into 19. Total would be, how many total functions are there? 20 into 20. So this 20 and 20 cancels, you get 19 by 20. Prajwal Nihara already given the perfect answer, which is 0.95, my dear friends. 0.95 is the correct answer for this. Is the idea clear? Super. Even this is a straightforward formula based question, nothing more than that. If you want to try, I'll give time for this, my dear friends. Number of onto functions. Number of onto functions. See, number of onto functions, we have a formula for that. Suppose set x containing 4 elements and set y containing 3 elements. The number of onto functions is given by the formula. It is given by the following formula, sir. 3, the number of elements in y, that is 3C0 into 3 power. See, this power always this x, number of elements in x, 3 power 4. See, first it is plus, then it is minus. 3C0, next one is minus 3C1. Now, 3 minus 1, 1 less than this, power 4. Now, after minus plus sign, 3C2, 1 less than this, 2 minus 1 is 1, 1 power 4. Actually, next term also you can write, that is 3C3, but 1 minus 1, 0 power 4 is anyhow 0. So, generally we ignore writing this particular term, my dear friends. Actually, this particular formula is derived using inclusion exclusion principle, my dear friend. Derivation is beyond the scope for class purpose, but this is the interesting formula which can be used to find number of onto functions from set x to set y. Am I clear? Of course, number of elements in x must be more than number of elements in y for onto function, my dear friends. So, what is it? 3 power 4 is 81, 48, and it is 3, my dear friends, which is 36 as Prajwal mentioned. Very good, Prajwal. So, that is about the problem. Please answer this question. Now, let us solve few graph theory problems which were asked in GATE, my dear friends. After graph theory, the final part would be like your relations, my dear friends. Let us see graph theory problems, then finally relations problems, my dear friends. Anyone trying? Lalit Yadav says D. Good. Lalit Yadav, you already know it. See, my dear friends, suppose this particular graph which is undirected, okay, can be constructed. Okay, can be constructed using this set of vertices. See, number of vertices equal to what? This is number of vertices and it is undirected graph. Okay. So, maximum number of edges. How many edges are possible? Okay. Actually, okay, very good, Lalit. Very good, very good. Maximum number of edges is NC2, because between two vertices maximum, because for every pair of vertices there is a possible edge. Am I clear? Maximum edges are possible between every pair of vertices. If there is a edge, that results in maximum number of edges, my dear friends. So, see how many 2 combinations are possible. N vertices are there. How many 2 combinations are possible? NC2 combinations are possible. Actually, strictly speaking, we have to mention number of undirected simple graphs. Otherwise, what happens? Between 2 points, I can have infinitely many edges, my dear friends. Okay, so generally they should mention it as number of undirected simple graphs, my dear friends. Am I clear? That is very important. Very good. Maximum number of edges would be NC2, which is nothing but n into n minus 1 by 2, my dear friends. N into n minus 1 by 2. So, if you consider the edges 1, 2, totally how many edges are there? N into n minus 1 by 2 edges are there. Now, for each edge, there are 2 possibilities. Either it belongs to your graph or it will not belong to your graph. Either the edge belongs to your graph or it does not belong to your graph, my dear friends. For each edge, there are 2 possibilities, belongs or not belongs to. So, total how many possibilities? 2 power n into n minus 1 by 2, my dear friends. Okay. So, that is the idea, my dear friends. Correct one. Your answer is correct, Lalit. Next one. See, they are all direct, straightforward questions, my dear friends, based on the knowledge, memory based or idea based questions only. See, connected, see, maximum edges means, see, when you have maximum edges with given number of vertices, it has to be connected only. Okay. If it is having maximum number of edges, how it can be disconnected, my dear friends? There are some rules about connected graph also. There we learn that idea. Anyone? See, there are two important graphs, and for this problem the most important graph is K33. See, K33 is like this. This is what we call it as K33, my dear friends. Complete bipartite graph. What is it called? Complete bipartite graph. And K33 is the planar graph. Okay, sorry, not planar. K33 is the non-planar graph. Non-planar graph with minimum number of edges. See, actually there is a Kartowski theorem, my dear friends. He proved that a graph is non-planar if and only if it does not contain or it contain a subgraph homeomorphic to K3 or K55. So actually these are the basic graphs which starts or which are your starting points of non-planarity, my dear friends. Okay, and K33, the greatness or the importance of K33 is it is the non-planar graph having the least number of edges. See, if you see K33 fellow will be having how many vertices, sir? It will be having 6 vertices. How many edges it will be having? 9 edges it is having. It's a straightforward question, sir. There is actually nothing to prove in this. It is just a direct result. I am just reading it out. Am I clear? We just need to know about K33 and Kartowski theorem if you know, direct answer, my dear friends. So it is a graph with how many vertices? 6 vertices. And how many edges? 9 edges. So what is the correct answer for this? What is the correct answer for this? Nine edges and 6 vertices. 9 edges and 6 vertices. That is the correct answer, sir. Not 3. 10, it is not having 10 edges, no, 9 edges only. Abhishek, 9 edges only, no, not 10 edges. This is about Eulerian circuit, Euler graph. Okay, a graph containing Euler circuit is what you call it as Euler graph. Now, this is a very interesting question, sir. Which of the following graph has an Euler circuit? In other words, you can say that which of the following graph is Euler graph. See, first thing for Euler graph, actually, Euler graph is the problem which is properly characterized. Happily, you can say the solution for this. Whereas there are so many other problems like Hamiltonian graph, planar graph, coloring, whatever, these are all not properly characterized. You don't have if and only if conditions for them. We don't have if and only if condition for them. But for Euler graph problem, we have if and only if condition. Perfectly 100% characterized problem. It is a 100% characterized problem, my dear friends. Which one? Euler graph problem. See, Euler graph means what, sir? Suppose you are having a graph. You start at any point. Okay. You can cover all the edges and come back to the starting point. And such a walk which contain all the edges of the graph, in which no edge is repeated, which starts and ends at same point is what we call it as Euler circuit. And a graph containing Euler circuit, or some people call it as Euler cycle, my dear friends, is what you call it as Euler graph, my dear friends. And you know, the simple method to verify a graph is Euler graph or not is, first thing is you have to check whether it is connected or not. And second is, degree of each and every vertex must be even. Yeah, last vertex can repeat, my dear friends. See, the terminology is not uniform among the people who discuss graph theory, my dear friends. So you cannot, Lalit, you cannot fix the terminology in graph theory. You always need to ask what is the underlying terminology. For example, what I call it as walk, some people may call it as path. What I call it as a trail, some people may call it as simple walk or some other walk, my dear friends. Okay. So with graph theory, the terminology you have to be very careful. Maybe you are studying nursing DO, then you may fix that particular terminology. If you go for Harare, the terminology is completely different. If you see Rosen, the terminology is quite different. If you see Kandel book or Tremblay Manohar book or Johnson Bach book, you take different books. No two books will have same terminology for this. So that is the problem with graph theory. You have to be very careful with that. Am I clear? Now look here, this is the idea. It should be connected and degree of every vertex must be even. Now first part, if you observe, K regular means a graph is called K regular if degree of every vertex is K, degree of every vertex is K, then you call it as K regular graph. And what he says, K is even number. Degree of every vertex is K. What is it? Degree of every vertex is K and K is even. Graph theory, if you want to understand, you have to see the graph, otherwise how you understand? See, actually generally I mention people that graph theory definitions are understood better way in viewing the graph than writing the definitions. Okay, so that's why, you know, the way they visualize, people given definitions and terminologies for graph, my dear friends. And one more problem with graph theory is discovered independently many times. Some person wants some graph theory, like Euler started this particular Euler graph problem, Königsberg bridge problem. He invented graph theory. Some other people read it with some, you know, nodes and edges connection. They started graph theory, so they have their own terminology, my dear friends. Am I clear? Now, can you say A option is Euler graph? Can you say A option is Euler graph? Degree of every vertex is K, where K is even. Can you say it is Euler graph? Why, Prajwal? No, fine. Why? See, my dear friends, this is two connected graph. This is my full two connected graph. Degree of every vertex is 2, but this is not connected. This is not connected. Therefore, option A is ruled out. What about option B? What about option B? Why? See, it's a complete graph. Complete graph Kn, degree of every vertex is n minus 1. In this graph, degree of every vertex is 90 minus 1. That is 89. Degree of every vertex is even connected, then it is Euler graph. But here it is bombed. Okay, so it is wrong. Now, what about complement of a cycle? Now, my dear friends, cycle with 25 vertices. Now look here, C25 is a cycle graph. Cycle graph, degree of every vertex is 2, my dear friends. Degree of every vertex is 2. Now, we are not talking about cycle, but we are talking about its complement. We are talking about its complement. Remember, sir, degree of a vertex in a graph plus degree of a vertex in its complement graph, same vertex, but in complement graph must be equal to total degree in a complete graph with that many vertices. For example, it is a graph with n vertices, that is its 25 vertices. No, degree of the vertex in the graph plus degree of the vertex in its complement should be equal to 24. But this is already 2, therefore degree of each vertex in the complement graph is 24 minus 2, which is nothing but 22, my dear friends. So in the complement graph, degree of every vertex is 22, and obviously minimum degree greater than or equal to n minus 1 by 2, then the graph is connected, my dear friend. There is one beautiful result. If minimum degree is greater than or equal to n minus 1 by 2, obviously it is connected. So both the conditions we established. Therefore, this C25 complement is Euler graph, my dear friends. C25 complement is Euler graph, my dear friends. Is the idea clear? See, my dear friend, discrete mathematics is not a topic like, just you attend and you answer the questions. It has to be followed throughout, because logic, if you want to understand, okay, directly a problem cannot be understood in logic or in graph theory, any of the topics. Of course, there are few topics like, functions, set theory, counting, okay, and of course, like relations. Some topics you can directly answer, but graph theory and logic, you have to strictly follow class, my dear friends. Okay, once you follow, the answers are direct. Most of the questions from discrete mathematics are standard questions, logic based questions, my dear friends. Okay, like that. There is a problem on planar graph, and planar graph is one of the important topic for GATE point of view. You can easily see around 15 questions based on planar graph only asked in GATE examination. Does 4th year syllabus is included in GATE? No, sir. Generally, 4th year syllabus is not included. Maybe for branches, I do not know, but for computer science, no. For computer science, no. Generally, all the subjects which we discussed, all the subjects like discrete mathematics will be completed by 2-1, okay, and data structure C mostly by 2-1 or first year only they will complete. Algorithm also 2-2 maximum they completed. Database management, CN, digital also will be completed by 2-1. Am I clear? COA, OS, they are all basic subjects. Maximum by 3-1 only most of the subjects which you study in your GATE will be completed, my dear friends. Am I clear? 3-1, third year first semester. By the time most of the subjects which are required for GATE will be completed. Am I clear? So, you can say 80% up to second year subjects, maybe remaining 20% you may find in your third year first semester, my dear friends. See, mathematics is very limited for computer science students. We have only 3 topics, that too they are all basic topics like calculus, linear algebra and probability. Whereas discrete mathematics, which you generally study in your second year first semester, that is one of the important topic for GATE point of view, my dear friends. Okay, yeah. Sharif, Ladka. Yeah. Now look at this, sir. In the first year you are trying to answer. Good for CSE. In our electrical engineering, even 4th year is counted. But you are electrical student and you are answering the questions of CSE, my dear friend. That is wonderful. That's why you say computer science is the easiest branch. If you properly prepare, you can complete the syllabus within 3-4 months also. Properly if you plan, 3-4 months you can complete the entire story. Things are very logical here. Okay, not much effort to the brain. Am I clear? It does not mean brain means so many results, so many things are not there. They are all plain, fair. CS people are very fair. Am I clear? Common sense is required. Right? Now look here, this is a graph having 10 vertices. Number of edges on each face is 3. See, we call it as degree of a region. See, this is called a region, sir, bounded by these edges. These are called edges bounding this particular face. This is either called face or a region. So, the number of edges in the boundary is what is called as degree of a region or degree of a face. So, degree of a region, what it says? Number of edges on face, each face is 3. That is, degree of each region is 3. Degree of each region is 3. Now, he is asking how many edges are there in this particular graph. So, it is simply based on this Euler's formula. V minus E plus R is equal to 2. If it is a connected planar graph, the number of vertices, number of edges and number of regions are connected by this particular formula, my dear friend, which is V minus E plus R. V is number of vertices, sir. So, V is number of vertices, edges you don't know, R you don't know, is equal to 2. He is asking how many edges are there. You have to find E, my dear friends. But they given one beautiful result. Degree of each region is 3, my dear friends. Degree of each region is 3. Am I clear? And each edge can be connected to or can be giving the degree to 2 regions, sir. It may give one particular degree here, it may give one particular degree here. And because degree of each region is 3, sum of degrees of region will be, because how many edges are there? Each edge contributes 2 degrees. Each edge contributes 2 degrees, my dear friends. Okay, so it is twice the number of edges. Generally, the sum of degrees of region will be less than or equal to twice the number of edges, because sometimes there may be interior edges like this. But here he clearly mentioned number of edges in the boundary of each face is 3. We ignore such internal edges, my dear friends. So we take sum of degrees of regions is equal to twice the number of edges. And what is degree of each region? 3. So it is sum of degrees of regions means 3 plus 3 plus 3. How many times? How many regions are there? That many times. So it is degree of each region is 3 plus and so on. 3 is equal to twice the number of edges. How many times, sir? How many regions are there? That many times. How many regions are there? R regions are there. Therefore, 3R should be less than or equal to 2E. Sorry, not less than or equal to, because he clearly mentioned each face is having 3 edges. So, 3R should be equal to 2E. Now, let us come back to our formula. V minus E plus R is equal to 2. V is 10. E we need to find. And from this, what is the value of R? Which is 2E by 3. Substitute 2E by 3 equal to 2. And now this is all simplification, sir. And you see how much work I am doing here. If you observe any of the previous problems also, hardly half page work I am doing, sir. Entire discrete mathematics is like this. But we need to know the results, connections we need to know. See, I need to connect this particular result with this, that will be there. That would be more in discrete mathematics, sir. Hardly how much work you do. See, this is all simple. Can you ask better or smaller problem than this? You need to find E value from this, sir. Can you find E value from this? So what is it? 10 minus E by 3 is equal to 2, or E by 3 is equal to 8, or E is equal to, oh, very difficult question I asked. Please complete that. (24) very good, Lalit Yadav. Okay. See, generally I don't suggest PYQ to be done in the beginning, but only to understand how this subject goes. You can try some of the questions. Of course, some people already completed, then they can try that PYQs, my dear friends. But without 24, Prajwal. A graph is self-complementary if it is isomorphic to its complement. If it is isomorphic to its complement, for all self-complementary graphs on n vertices, n should be equal to what? Actually, if you know direct result, you can directly write the answer like this. Without even thinking, I will write the answer for that. But here you want to solve a problem, I am just giving you the idea for this. See, if E is number of edges in the graph, E complement is number of edges in the complement of the graph. Sum of edges must be equal to total number of edges in a complete graph, my dear friends. Because complement, what is complement, my dear friends? A complement of a graph is obtained by connecting the edges which are not originally connected, or connecting the vertices which are not originally adjacent. Okay, which are not originally, yeah, it's a direct theorem, sir, which are not originally adjacent. So the edges which are not there in G, that will be present in G dash. So if you combine both the edges, you are going to get edges in a complete graph, my dear friends. How many edges are there in complete graph? N into n minus 1 by 2. But because this fellow is self-complementary, complement to itself, the number of edges in graph is same as number of edges in its complement. The number of edges in the graph and number of edges in its complement both are same. Therefore, E plus E is equal to n into n minus 1 by 2. That means 2E is equal to n into n minus 1 by 2. That means E is equal to n into n minus 1 by 4, my dear friends. So, number of edges is of the form n into n minus 1 by 4. But it should be an integer. Edges cannot be a fraction. No, it cannot be 2.1, 2.3 like that. It has to be an integer. It has to be an integer. So, when n into n minus 1 by 4 is an integer, either 4 should divide n or 4 should divide n minus 1. That means n by 4 must be some k, or n minus 1 by 4 must be some k integer. That means n is equal to 4k, or n minus 1 is equal to 4k, or n is equal to 4k plus 1, my dear friends. And that is exactly congruent to 0 modulo 4. That is, if it is multiple of 4, what happens, sir? It should be congruent to 0. congruent to 1. 4k plus 1 means it is congruent to 1 modulo 4. When you divide by 4, the difference, okay, the remainder would be 1, my dear friends. If it is of this particular form, it is congruent to 1 modulo 4. When you divide by 4, what will be the remainder? 1. If you divide by 4, what is the remainder? 0 for this. That is, it is congruent to 0 mod 4. When you divide by 4, remainder is 0 here. When you divide by 4, remainder is 1 here, my dear friends. Like that. So, that is the answer for this. Direct result, my dear friend, nothing more than that. Hope you understand. This is a direct statement, my dear friend. You just need to identify, you need to know about, what is a bridge. Okay, nothing more than that. A tree has no bridges. What do you mean by bridge, sir? A single edge. If you remove it, graph get disconnected. In tree, every edge is a bridge. In a tree, every edge is a bridge. Bridge or cut edge, you call it. And tree has no bridges is wrong, because every fellow is bridge. You are saying no bridges. Wrong. A bridge cannot be part of simple cycle. Yes. See, my dear friend, if you take a cycle, simple cycle, if you remove, see, from cycle, if you remove the edge, graph does not get disconnected, sir. Bridge means what, sir? If you remove the edge, graph should get disconnected. So, in a cycle, no edge is a bridge, because even if you remove the edge, graph is still connected only. Am I clear? So, B is the correct answer, my dear friends. Now, this click means complete subgraph of a graph. So, complete graph means what, sir? Every pair of vertices are connected. See, cycle itself, if you remove the edge, it is not getting disconnected. How click can happen, sir? Click is a complete subgraph. So, obviously, every edge of click is a bridge is wrong, because click is much stronger than cycle. Cycle itself is not having bridge. How can click can have? So, that is also false. A graph with bridges cannot have a cycle. Now, this is where people misunderstand. See, if the edge is in the cycle, it cannot be a bridge. But I can have a graph in which I can have cycle, and I can have a bridge. See, if you remove this edge, graph get disconnected. But this is having cycles also. So, if graph with bridge cannot have cycle is wrong. It can have cycle, my dear friends. It can have cycle. No, it's not about, see, B is talking about cycle edges. It is not talking about cycle. Graph में cycle है, but still edges can be there which are cut edges or bridges. That is the question, my dear friend. There is a difference between B and D, my dear friends. There is a difference. Now we are having problems on relations. We take up 2-3 problems from relations to call it a day, my dear friends. Of course, see, for discrete mathematics, we should have some prerequisite. I don't know, most of the people are not interested in discrete mathematics. The problem is most of the people do discrete mathematics towards the end, which is actually unfair practice. You have to start with discrete mathematics, which improves your logic, okay, analytical capabilities. But generally what people do, discrete maths, they see mathematics not towards the end they do it. Don't ever do that, my dear friends. Try to do at the earliest, because discrete mathematics is the foundation course, and most of the topics which you study in your discrete mathematics are useful in all the topics. Let it be your C programming, data structures, algorithm, theory of computation, any topic you take it, all logical topics like DBMS, relational algebra is based on discrete mathematics only. Am I clear? Yeah. So, which of the following is equivalence relation? What do you mean by equivalence relation, my dear friends? Equivalence relation means a relation which is reflexive, symmetric and transitive. If a relation is reflexive, symmetric and transitive, we call it as an equivalence relation, my dear friends. A relation which is reflexive, symmetric and transitive is called equivalence relation, my dear friends. Okay. Now, first one, R1. What it says? A related to B if and only if A plus B is even. A related to B if and only if A plus B is even. Now, we will check whether it is reflexive or not. Reflexive means A should be related to it itself. That is, you consider A plus A. What is A plus A, sir? 2A, which is even. Because A plus A is even, which means A related to A. Therefore, it is reflexive, my dear friends. It is reflexive. This is reflexive. Now, A related to B means what, sir? A plus B is even. Now, when A plus B is even, obviously B plus A is also even, my dear friends. Correct? That means B is related to A. Therefore, it is symmetric also. So, this first relation is reflexive. It is also symmetric. The next one is it transitive? Is it transitive? So, what we need to do is we consider A related to B and B related to C, my dear friends. A related to B and B related to C. What is A related to B, my dear friends? A related to B means what? A plus B is even. And B related to C means B plus C is even. See, what do you mean by even, sir? When sum of two numbers will be even, if both are even or both are odd, then only sum will be even. Suppose here both are odd, B is odd, here also C must be odd. Therefore, A plus C also becomes even, my dear friends. A plus C also becomes even. And suppose if both of these fellows are even, because E is even, C must be even, so that their sum is even. So, if you consider A plus C, that also becomes even. That is, whenever A related to B and B related to C, then A related to C, my dear friends. See, the logically same question may not be repeated, but in discrete mathematics, there are some questions which were repeated with slight changes or direct also, my dear friends. Because it is a logical topic, no? Some direct questions are there, some direct relations are there which can be asked directly with slight variation in the question, my dear friends. Patterns, you can get similar patterns in the examination, my dear friends. Similar patterns you can get. Am I clear? A related to C, my dear friend. Therefore, it is transitive. So, here R1 is equivalence relation. See, R2 is not equivalence relation because he says A plus B is odd. How A plus A is odd, my dear friend? Because A plus A is 2A, which is even. So, because of this, it is not reflexive. Therefore, it cannot be equivalence relation, my dear friend. It cannot be equivalence relation, my dear friends. Now, what about R3? A into B. Let me solve R3 here. A into B greater than 0. You know that A into A is A square. Because it is non-zero real rational number, no? A square is obviously greater than 0. That is what you want. Therefore, it is reflexive. Reflexive means A is related to A. Now, suppose A is related to B. What do you mean by A related to B, sir? A into B is greater than 0. See, if A into B greater than 0, B into A is also greater than 0. That means B related to A. Therefore, A related to B gives B related to A. Therefore, it is symmetric, my dear friends. Okay. Then comes transitive. Let us assume that A related to B and B related to C. Means what? A into B is positive, B into C is positive. When product of two numbers is positive, sir, when both of them are positive, both of them are negative. Suppose if B is positive, C must be positive. That means A into C also positive, my dear friends. Because A positive, C positive, their product will be positive. Suppose B is negative, C also must be negative. In this particular case, A into C both are negative. Even in this case, A into C is positive. That means what, sir? It is transitive, my dear friends. It is transitive, my dear friends. Therefore, what you can understand? This particular relation is also satisfying reflexive, symmetric and transitive. It is equivalence relation, my dear friends. And if you observe the last one, R4, mod A minus B less than or equal to 2. Actually, if you verify this is reflexive, this is symmetric, but it cannot be transitive. I will give you a simple example for that. You consider mod 2 minus 4 is less than or equal to 2. Mod 4 minus 6 less than or equal to 2. But if you consider 2 and 6, that is mod 2 minus 6, which is 4, which is not less than or equal to 2. Therefore, transitive property fails. See, whenever you want to disprove something, you just need one counter example, my dear friends. To disprove something, you need a counter example. To prove something, you need to prove the entire story like this or what I done here. But here I just want to disprove it. I just given a counter example. Because this is not transitive, it is not equivalence relation. Only R1 and R3 are equivalence relations, my dear friends. R1 and R3. R1, R2 wrong. R1, R3 yes. Yes, B is the correct answer, my dear friends. B is the correct answer, my dear friends. And even this is straightforward gate question. There is no twist, nothing in this, my dear friends. Okay. So, a set is having n elements. What is the equivalence relation on the set containing minimum number of elements? There is something called delta relation, equal to relation, 1, 1, 2, 2, 3, 3 and so on, nn. This is the smallest equivalence relation, and this fellow contain how many elements? N elements. And the largest equivalence relation is S cross S. S cross S is the largest equivalence relation, and how many elements are there in this? N square. So the largest and smallest equivalence relation on S containing how many elements are? N square and N elements respectively, my dear friends. My dear friends. Okay. See, these are some gate questions, my dear friends. We also have some very important questions, but we discuss some very important topics and very important gate questions today. Next time, sometime or later on, we try to discuss the concepts, then the questions would be more interesting, my dear friends. Okay. So if you have any other doubts, you can ask me. Otherwise, because I discussed some of the important questions in this particular video, hopefully you like this. Okay. And tomorrow morning, we again continue with our C programming, that is class number 10th, that is functions topic, my dear friends. Functions in C programming. If you have any doubts, you can ask me. Otherwise, we'll call it a day, my dear friends. Data structures. See, data structures, whether I discuss all the topics or few topics, we'll discuss, sir, because you know we need to have once C programming is completed. Am I clear? See, for 1 or 2 members, obviously I will not be doing it, sir. If more people are interested, I will do it. Am I clear? See, once C programming is completed, then I will propose for my next subject. If more people are interested, obviously I will do data structures, I will do algorithms, even discrete mathematics if time permits, my dear friends, obviously. Am I clear? Yeah. Sure, sir. But the schedules on YouTube are dynamic. After completing one topic only, we can go for next one. Am I clear? Of course, on BYJU'S Exam Prep app also, there are some videos which were already recorded. Some of those videos you can directly see if you download BYJU'S Exam Prep app, my dear friends. Learn with video lessons. There you can see some of the videos for free. Okay? Learn with video lessons. Okay, Prajwal. Of course, there are some more questions, but I think we already delayed by a long time. Nice. Anyhow, we gone through some of the important, all the topics we covered, all the topics we touched. Okay, because some problems are there, but for them we need to have some prerequisite. Without them, if you solve it, it's just like a solution on the YouTube, nothing more than that, my dear friends. Okay, fine. If you have any other doubts, you can ask me. Definitely, surely, Prajwal, I'll come up with some more topics on YouTube, my dear friend. Data structures topics like trees, they are very interesting for me, for us. Like linked list, trees, stacks, queues, all these concepts we can discuss, my dear friends. Okay. Definitely, surely, I'll come with some more topics. Okay. So that's all for today. If you have any doubts, you can ask me. Otherwise, that's all from my side, sir. Thank you. Thank you.